We're now on our solution video, our rationale to the operations of algebraic expressions. So these are the exercises. It's particularly found on your page number 4 on your respective modules. So maybe you can watch this video right after you have answered that. Okay, so that you could have some practice of your own before you even get the solutions, right? So let's start. So for the first question, it's about addition of algebraic expressions. So let's put a big plus sign over here. Okay, and we'll have a bar here. Let's make that straight. As straight as possible. Okay, now let's try to, what do you call it? Let's try to give some um what do you call that? Some remembrance, or shall we say some tick marks of the like terms here, so that we won't get confused. So for the x squared, we can see an x squared here, an x squared here. So maybe we can, let's try to encircle first all the x squareds, including their signs. Okay, there's no other. Here we go. Here's also another x squared. Okay, so no other x squareds, I believe. Yes. Next is we're going to box the y squares. Okay, so you also have a y squared here. Where else? This one. Oops, sorry. This one is also a y squared. Where else? Here. Oh no, no, that's a z squared. Okay, next, let's put inside the triangle all the z squareds. This is also at the z squared. Let's put that in a triangle. Okay, what else? XYs, all the XYs. Can we put that in a also in a circle? Let's put just a mark here so that we won't get confused. XY. This is also an XY. This is also an XY, and this is also an XY. And take note, this is a -6. Okay, how about the YZ? So we have two YZs, three rather. This is also a YZ. What will I do? Put two circles, I believe. One, two. Okay, for the YZ, this is also a YZ. Two circles. This is also a YZ. And notice that XZ is a loner. Okay, there's no other what do you call that, like terms for that, but we have for the constants, we do have that. So we have -5 plus 10. Maybe we can just add that without any tick marks, so that it will be easier for us to see. Okay, so let's try to have our addition now. As you can see, if we have some tick marks here, it's pretty much easy to see the like terms, compared that there's none. Right, compared that there's none. So let's try to add first all the x squared. So we have -2x, or rather 2x squared, 2x squared. Where's the circles? Here. So 2, since they're all x squared, so I think we can copy the x squared already. We just need to combine the new coefficients. 2, can we just put across if we have chose that, so that we won't get confused? -3 plus 1, where here. Oops, sorry. -4. So what's the answer? 2 minus 3 is -1. -1 plus 1 is 0. So that will leave us -4 x squared. Okay, next is the y squared. So for the y squares, let's start with 3. So let me put the y squared already. So -3. Where else? The boxes, we have -1. We have +3. Okay, so -3 plus 3 will become 0. So we have -1. Copy the sign, -1 y squared. Or maybe we can just don't write the 1. Okay, that's okay. Minus y squared, or 1y squared. Next up, we're going to write the z squared. Let's write the z squared already. So where the z squared, they are inside triangles. We have 1 triangle. Here we have -7. Where else? Triangles, 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 triangles. There's none, right? There's no more triangles. Yep. And the answer is 1 minus 7 is going to be -6. -6z squared. Okay, and then let's try to combine first x and y so that it will be systematic somehow. X and y. So for the x and y, they are with a single, what do you call this? Loop, shall we say? So we have minus 4. Let's put it here. Minus 4. Single loop, single loop, single loop. Here we have, oops, sorry. We have plus 2. Single loop. We have plus 5. We have minus 6. Oops, sorry. So minus 4 plus 2 is minus 2. Minus 2 plus 5 is positive 3. 3 minus 6 is minus 3. And oops, we forgot this. 8. Where were we again? This is positive 8. Oh, sorry, sorry. Let me check that again. So 1, 2, 3, 4. Right? These are all the xy's. Oh, let's check xy, 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 xy. Pretty much that's all the xy's. So again, minus 4 plus 2. Minus 4 plus 2 is going to give us negative 2. Negative 2 plus 5 is going to give us 3. Minus 6 plus 3 is going to give us um, plus, minus 3. Okay, minus 3. Okay, next up, let's find the xz. So we have only one xz here. There's no other xz's, right? So we will only need to write one xz, and that's it. That's plus. This is it. This is the xz. There's none. There's no other xz's. And then let's combine the xy's then. X, or rather the yz's, rather the yz's. Okay, so yz's, we have two dupes. We have 5, we have 1, we have 8. Oops, sorry. We have 8. So we have 5. They're all positive, right? Yeah, they're all positive pretty much. So 5 plus 1, 6 plus 8 is gonna give us 14. Okay, so that's positive plus 14. Okay, and then lastly, 10, oops, sorry. 10 minus 5 is gonna give us plus 5. And this is your answer for your number 1. Can we make use of the green or orange? Not, no, not really. Green. Green will do. Okay. Green pen. Okay. So kindly check there. Maybe there are some errors in your solution key. Okay. If ever there are some, well, that's my bad. Okay. But this is the correct answer now. Since in your example, there's only one xz given. Okay. There's only one xz given. Or maybe I found a mistake. This is written incorrectly in your module. This should be xz instead of xy. Okay, so just take note in your module. There's some error there. This should in your module. This is written as xz instead of xy. So these two terms might be quite different from your solution key. Okay, but if you have wrote there minus 5xy and plus 3xz, you're correct. Okay, you're correct. Okay. So that's for the number 1, though it's quite written wrongly. But let's proceed to number 2. Okay, for number 2, what we're going to do is subtract. I think it's better to put the bar here, and it's much safer to put a parenthesis here. And what we're going to do is to distribute all the minus signs here, and by the virtue of our laws of removing the grouping, all these signs will be flipped, will be changed, flip and change. So this will become, let's make this, you know, this becomes plus, this becomes plus, this becomes minus, this becomes plus, this becomes minus, and this becomes plus. Okay, so let's solve for this number. So we have a squared plus 4ac. Okay, so what is your answer? A squared minus, or rather a squared plus 4ac. What's the answer? A squared plus 4ac is gonna give us, oh, sorry, that cannot be done. Sorry, sorry. Where was I? So a squared. This is a squared. Let's find the like signs rather. This is the like sign of a squared. I'm very sorry. I thought this is a squared. Next up is the b squared. Let's put that in a rectangle. This is b squared. This is also b squared. This is negative 5b squared. And no more. The c squareds, let's put that in a triangle. This is also a c squared. And the d squared, let's put it in a circle with a single loop. D squared. Okay, so a squared plus 2a squared is gonna give us 3a squared. Okay, and then 2 b squared minus 5b squared. So they're both negative. So it's going to become 7. Copy the sign. B squared. And then for the c squared plus 4c squared. Okay, so 1. Imagine there's a 1 here, which is invisible. 1 invisible 1. So 1 plus 4 is going to give us plus 5c squared. And then lastly for the d squared, minus 3 minus 5 is going to give us minus 8d squared. Let's use the green. There's some typographical error in the solution key. What happened there is that the 5 is written here. Okay, the 5 is written here, so kindly make the necessary changes. Okay, it should be written here, just like that, just like this one. Okay, so that's for number 2. For number 3, find the product of the given expression. So likewise, we will do the what do you call that? The distribution of terms. So first up, we will multiply 2x to the fifth by this, and then multiply this here, and then this term, multiply it here, multiply it also here, and then we will multiply it here, and then also here, the minus 6 here, and 6 there, here, multiply it here and here, sorry, here and there, and then here lastly, and this one. So let's do that one by one. Okay, this is quite tasky. So 2x to the fifth times 3x is going to give us 6x to the fifth. 2x to the fifth times positive 5 is going to give us plus 10x to the fifth. Okay, or rather this should be to the sixth. My goodness. 6x to the sixth, since we have a 1 here, right? So x to the fifth plus 1 is gonna become 6x to the sixth, and then likewise 10x to the fifth will be the next term, and then 3x squared times 3x, so that's gonna become 9x cubed. Why is it cubed? 2 plus 1, so 9x cubed, and then add or multiply 3x squared by 5, that's gonna become 15x squared. Square only because it has no constant here. And then we're here with the negative 4x cubed. Negative 4x cubed minus, or times rather, times 3x. 4 times 3 is 12. Since this is negative, so we have negative 12. Should be negative 12x to the fourth. Since this is 3, this is 1, so we add, and then multiply that by 5. That's going to become negative 20. Since 4 times 5 is 20, x cubed. Okay, we're still here. We're done here, we're done here, we're done here. We're here now with the 6. Minus 6 times 3x is going to give us minus 18, since 3 times 6 is 18x. And then minus 6 times 5 is minus 30. Okay, now we're here. 7x to the fourth times 3x, so 7 times 3 is going to give us 21 plus, sorry, plus 21 x fourth plus 1 x to the fifth, x to the fifth. Okay, and then x 7x to the fourth times 5. 7 times 5 is going to give us 35. This is going to become plus 35x fourth to the fourth. And then I think we cannot fit it there. Let me continue it here. 2x times 3x is negative 6x squared, and then 2x times 5 is negative 10x. Whew, okay, so that's it. We're done. And then what we need to do is to combine the like terms, we will find the like terms here. For the 6x to the 6, there's no like terms for 6x to the 6. For to the x to the 5th, we have 2. This one and this one. If we will combine that, so we have 10 plus 21 x to the 5th. Okay, so what's the answer there? 10 plus 21, that's going to give us 31 x to the 5th. So let me put the solutions down here. So we have 6 x raised to 6 plus 31 x to the 5th. Okay, next up is x to the 4th. X to the 4th is over here and over here. So negative 12 plus 35. So we're like subtracting 35 minus 12 is gonna give us 23, and copy the sign of the big number. So that's positive 23 x to the 4th. Positive 23 x to the 4th. Let's go to the cube now. This is cubed, 9x cubed, and this is 20x, negative 20x cubed. So 20 minus 9 is 11. Copy the sign of the bigger number, negative. So what we have is negative 11x cubed. Negative 11x cubed. Let's go to the squared this time. Squared, 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 squared. Here we go. So can we just box this? It's too much underline already. 15x squared, and we have the here minus 6x squared. So 15 minus 6 is going to give us 9. Copy the sign of the bigger number. That's positive. So what we have is positive 9x squared. Okay, and we're done with the x with degree 1. So with x with a degree 1, we have here is 18. We'll encircle that. Minus 18x, and we have minus 10x. So minus 18x plus negative 10x, so they're both negative. We're going to add them and copy the sign. So that will lead us to negative 28x. And for the constant, we have one constant. We have minus 30, so copy the minus 30. Likewise, in our 6x to the 6, it has no common like term. And that is our final answer for this number 3. This is the multiplication. Okay, let me back this, and this will be our answer for number 3. I think that's pretty much the same with from your solution key. Let me double check. 11x cubed plus 9x squared minus 28x minus 13. Yeah, that's pretty much the same. Well, that's correct. That's good to hear. Okay, good to know. Number 4 for the last one. So perform this operation. Obviously, this is the operation here is division. Oops. Division. Anyways, to let you know already in our quiz, this will not be the division in our quiz. The division in our quiz will be quite the same with the long division in the video, in that long video. Okay, so this is like just an exercise for monomial by monomial. But in the quiz, you will be having the long division. Okay, that is polynomial by the polynomial. So kindly practice already. So let's simplify. 30 divided by 3 is 10. Since they're not the same sign, so it's gonna be negative 10 clearly. And x squared, okay, x squared divided by x, so x squared over x, this is equal to x 2 minus 1, since we have 1 here. So 2 minus 1 is just equal to x raised to 1, so we can just write x. Okay, and then y cubed over y, so y cubed over y, so we have y, this is raised to 1, 3 minus 1, so this is gonna leave us with y squared. And then z raised to the power 4 over z squared, so we have z 4 minus 2 equals z raised to 2, so we have z squared. And this is our final answer, our solution for this number 4. Okay, so hopefully you got correct there in our exercises in the module. Only some errors in number 1. I overlooked it. I typed y instead of z, so the correct answer should be with this instead of this blue ink. Instead, it should be this if you have answered it from the module. So I have wrongly copied it here in the slides. For number two, this is the correct answer. Okay, this is the correct answer. Maybe some errors from the module also. Okay, overlooked by the C. Okay, or the typographical error on the C. For number three, so this is the correct answer. Okay, and number four, this is also the correct simplified answer. So that ends our rationale for the exercises in the operations of algebraic expressions found in your module. So in order to practice algebra, like I always say, or in order to master algebra, the key is practice. I said it already. So the key is practice. I hope you will also do your part to practice, since learning or mastering mathematics is not an overnight um, magical power, okay, or an overnight skill that can be mastered. So it takes practice. So one should practice also. Okay, so kindly get ready for the quiz. It will be posted shortly. Just take note of the updates. Okay, so thank you so much. Kindly like this video and subscribe to my channel. Thank you very much and see you soon. Bye.